What you are about to see challenges everything you think you know about where your clothes come from. We have been conditioned to believe that soft, durable, and luxurious textiles can only be spun from cotton fields, petroleum-based synthetics, or the slow labor of silkworms. But standing right here on the production floor of one of the most advanced agricultural processing facilities on the planet, that assumption is being shredded by massive, deafening machines. You are looking at mountains of what the outside world considers agricultural waste, the massive, heavy, green trunks of banana plants, freshly cut from sprawling plantations and arriving by the truckload. To the untrained eye, this is nothing more than discarded biomass destined to rot back into the earth. But to the engineers and technicians running this highly calibrated industrial line, these towering stacks of banana pseudostems are a highly prized raw material, a reservoir of incredibly strong, naturally antibacterial, and breathable fibers that are about to undergo a radical metamorphosis. We are stepping directly into the blind spot of modern textile manufacturing, a sprawling, heavily automated factory where the bulky, moisture-rich stems of the banana plant are systematically dissected, crushed, washed, and refined into a pristine natural fiber that will ultimately be woven into high-end women's underwear. This is not a rustic, village-level hand-weaving operation. This is large-scale, precision-engineered industrial fiber extraction, a symphony of aggressive mechanical forces and delicate chemical balancing acts that takes a spongy, waterlogged tropical plant stem and transforms it into a silk-like thread capable of competing with the most premium fabrics on the global market. The sheer scale of this operation is breathtaking, with conveyor belts carrying 100-pound stems, high-pressure water jets cutting through dense cellulose, and automated sensors adjusting tension and moisture levels in real time, all orchestrated to ensure that the final textile is perfectly suited for the most intimate and demanding of human applications. As we move deeper into the facility, the air grows thick with the earthy, green scent of freshly broken plant matter and the sharp, clean aroma of the alkaline baths used to strip away the natural gums. The noise is a constant, heavy rhythm of steel against organic matter, a mechanical heartbeat driving a process that few consumers will ever witness, turning a 100-million-year-old evolutionary design into a 21st century sustainable textile. The journey begins at the receiving dock, where an endless stream of flatbed trucks dumps freshly harvested pseudostems onto a reinforced concrete floor. These are not tree trunks in the traditional botanical sense, because the banana plant does not produce woody tissue. Instead, this massive cylinder is a pseudostem, a tightly packed vertical stack of overlapping leaf sheaths, each one wrapped around the other like the layers of an immense leek, holding massive reserves of water and structural fibers. Workers wearing heavy-duty gloves and steel-toed boots move rapidly, using specialized hooks to drag the stems onto the primary intake conveyor, a heavy rubber belt moving at a precisely calculated speed to feed the first wave of machinery without causing a bottleneck. The stems vary in thickness and length, presenting the first major engineering challenge of the day, standardizing a completely non-standard organic input. As the conveyor carries the raw pseudostems into the belly of the factory, they pass under an array of high-pressure water nozzles that blast away the outermost layer of dirt, mud, and field debris. This initial wash is critical, as any grit or sand allowed past this point will severely dull the industrial blades waiting further down the line, leading to costly maintenance shutdowns. Once cleared of surface soil, the stems enter the decortication zone, the most violent and visually spectacular phase of the entire process. Here, massive, rotating drums equipped with hardened steel beater bars seize the spongy pseudostems and pull them through a narrow gap against a stationary counter-rotating drum. The resulting impact is staggering. The machine does not cut the stem, it shatters it. The heavy steel bars literally pound the water-filled, fleshy green tissue of the leaf sheaths into a wet pulp, simultaneously crushing it and tearing it apart, leaving behind only the tough, resilient vascular bundles that run vertically through the plant. These bundles are the banana fibers, and as the pulpy green mush is blasted away by another series of high-pressure water jets, long, ribbon-like strands of pale, luminous fiber emerge from the other side of the machine, looking almost like wet, golden horsehair. This is raw decorticated fiber, but it is far from ready to become underwear. At this stage, the fibers are tangled, varying wildly in thickness, and still bound together by a complex matrix of natural gums, pectins, and lignins, the biological glues that hold the plant's cellular structure together. If you were to touch this freshly extracted fiber, it would feel incredibly tough, almost like a coarse scrubbing brush, and it would be stiff and unyielding. To bridge the gap between this rugged agricultural byproduct and the soft, supple fabric required for intimate apparel, the fiber must undergo a rigorous sequence of biochemical and mechanical refining. The tangled ribbons are immediately conveyed into massive industrial washing vats, where they are tumbled aggressively in baths of cold water to remove the last physical remnants of the pulverized plant tissue. From the washers, the wet fiber is mechanically dewatered using heavy squeeze rollers, and then dropped into a series of massive, heated chemical tanks. This is the retting and degumming phase, the delicate alchemy of the factory floor. The exact chemical formulation is a closely guarded industrial secret, but it generally involves a carefully controlled alkaline solution, often utilizing natural enzymes or mild caustic sodas, heated to specific temperatures to break down the pectins and lignins without degrading the cellulose that gives the banana fiber its incredible tensile strength. The fiber sits in these bubbling, agitated vats for hours, slowly softening as the rigid molecular bonds holding the rough outer layers to the inner core are dissolved. Workers stationed at catwalks above the vats periodically pull out small sample strands, snapping them between their fingers and rubbing them to test the progression of the degumming process. They are looking for a specific tactile feedback, a shift from a harsh, scratchy grip to a smoother, more pliable feel. Once the target level of gum extraction is achieved, the fiber is subjected to a neutralization wash, pulling the alkaline pH back down to a neutral state, followed by a final series of softening rinses that may involve natural vegetable oils or bio-based softeners. This softening step is absolutely vital for the end goal of this specific production line. Because this factory's output is destined for women's underwear, the fiber cannot just be strong. It must be luxuriously soft against highly sensitive human skin. The natural structure of banana fiber is inherently hollow, allowing it to breathe and wick moisture far better than cotton. But that same structure can feel prickly if the microscopic barbs on the fiber's surface are not smoothed out. The biosofteners coat the individual cellulose strands, lubricating them and reducing surface friction, prepping them for the brutal physical friction they are about to endure. The softened, degummed, and washed fiber is now a completely different material than what entered the decorticator hours earlier. It has transitioned from a muddy, tangled agricultural waste product into a clean, pale cream-colored mass of fine, silky strands. But the transformation is only halfway complete. The fiber must now be dried, combed, and spun into a continuous thread. The wet fiber is fed into industrial centrifugal spin dryers that whip the water out at tremendous G-forces before being spread thinly onto massive, miles-long conveyor belts.